Designing EMI shielding that delivers high performance without adding any additional weight or cost is a challenge that many engineers face. This is especially true in applications where space and efficiency are at a premium. Traditional shielding materials like copper or stainless steel are effective alternative choices, but can introduce compromises such as system weight, cost, and ease of fabrication. Aluminum wire mesh offers a lightweight, cost-effective alternative without sacrificing essential shielding performance. Its natural conductivity, corrosion resistance, and formability make it an increasingly attractive choice for engineers working in aerospace, automotive, and consumer electronics sectors. In the electromagnetic interference industry, the effectiveness of your shielding often hinges on the material that you choose. While denser materials like copper and stainless steel are commonly used, they aren't always the most practical for your application. This is particularly true in weight-sensitive environments like aerospace, electronic vehicles, and portable electronics. Aluminum wire mesh presents a fantastic alternative to heavier metals. Its high strength-to-weight ratio allows engineers to reduce overall system mass without compromising shielding integrity. This not only supports efficiency and optimization, but also contributes to easier installation and handling in complex assemblies. Aluminum's natural conductivity makes it suitable for material for EMI attenuation, especially in applications that don't require the extreme shielding levels provided by heavier metals. And because it's highly corrosion resistant, aluminum wire mesh remains effective in outdoor or human environments where long-term effectiveness is crucial. Ultimately, aluminum's value lies in its ability to provide reliable EMI protection in systems where weight matters. It enables more efficient, streamlined designs while still supporting essential shielding functions. Developing an effective system for EMI shielding often means managing trade-offs between conductivity, weight, cost, and mechanical strength. Aluminum wire mesh offers a balanced solution and delivers the shielding performance engineers rely on while supporting overall system efficiency. Thanks to its moderate conductivity and its fine wire diameter capabilities, aluminum mesh can effectively attenuate EMI across a broad frequency range. While it may not match the conductivity levels of, say, copper, aluminum's performance is often more than sufficient for most commercial and industrial applications. In fact, for systems with moderate EMI exposure, aluminum wire mesh achieves excellent attenuation while eliminating the burden of unnecessary weight. This balance is especially important when designs must optimize for thermal management, portability, or power consumption. Because aluminum is significantly lighter than its alternatives like copper and stainless steel, it reduces structural loads and enables more compact, energy-efficient solutions. And what's more, aluminum's natural oxide layer adds a layer of corrosion protection, making it a practical choice for harsh or exposed environments where long-term reliability is a concern. It also tends to be more cost-effective, making it a go-to material when the project calls for both performance and value. While stainless steel and copper are often top of mind when it comes to EMI shielding solutions, there are many scenarios where aluminum outperforms them, particularly when weight, cost, and corrosion resistance are critical design factors. In aerospace and automotive applications, for example, weight matters to a critical degree. The use of aluminum wire mesh allows engineers to reduce overall component weight without sacrificing electromagnetic compatibility. This is essential for improving fuel efficiency, meeting regulatory standards, and enhancing overall system performance. Aluminum also holds an edge in portable electronics and enclosures where weight savings contribute directly to user experience and thermal efficiency. Devices become easier to handle, and heat dissipation improves without the need for bulkier shielding components. In corrosive or moisture-prone environments, aluminum's natural forming oxide layer provides passive protection against degradation, reducing the need for secondary coatings or treatments. Compared to metals like copper, which can oxidize and lose conductivity over time without plating, aluminum offers more predictable long-term behavior in such conditions. And in large-scale applications, such as telecom cabinets or industrial enclosures, aluminum's lower cost and ease of fabrication make it a practical choice when budgets are tight, but EMI compliance remains non-negotiable. Thanks so much for watching. If you have any question, click our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.